A calculus problem here, a calculus problem that involves finding the area between two curves. Before we do, we need to find some intersections. We need these 2 points where these two functions are equal, and we have y equals 9 minus x, and we have y equals quadratic x squared minus 2x plus 3. This is quite nice. We've got a y equals and a y equals, so we can get y equals y. So 9 minus x will need to equal x squared minus 2x plus 3. And this is a quadratic, so it must be set to 0. X squared minus x minus 6. And rather nicely, it will factorise. 2 3's are 6, minus 3x plus 2x gives me the minus x, and so I've got x equals minus 2 or x equals 3 to 0, both those brackets, and that will give me 3. And I'll go back to this one as being the easiest. I can go back to either, but that's easier to find the y coordinates. 9 minus 3, that's 3, 6. And this coordinate here, minus 2, 9, minus 2, 11. So now I need to start thinking about integration and areas under curves. For this, because I'm trying to find the area between, what I will be doing is I will be taking the upper curve and I will be subtracting from it values from the lower curve. And if I do that, what will happen is upper curve minus lower curve will give me these values in between. Upper minus lower will give me the distance in between, and if I integrate along, then I will get the area between. So a standard way to find the area between curves is to do 2 integrations. Integration of the one above. Well, let me just get my pens right. Integration of the curve above minus the integration of the curve below, and in the end what that will give me is one single integration, an integration of the curve above, 9 minus x, I'll do it all together, minus the curve below, and if I do this between minus 2 and 3, I will get what I need. So standard method here, that is worth making sure you're aware of. The 2 curves can be subtracted to find the distances in between, and if we add all that up between the limits, we will get the area we're after. So let me tidy this integration up a little bit first, and I have 9 minus 3, 6, minus x minus 2x plus x minus x squared dx. And if I integrate, square brackets, 6 goes to 6x, powers go up and divide by, power goes up and divide by, and then I substitute 3 in, I substitute minus 2 in, and I should subtract, get the answer. And minus 2, so minus 12. And this will give me 18 plus 9, this will give me 13.5. minus, this one is minus 7 1/3, and that will give me 20 and 1/2 plus 1/3, 20 and 5/6. There's my area. And I'm just going to do a quick check of this, rather neat way to check, and we will have a look at Wolfram Alpha and let's see what it says. So integrate. Already got that wrong, I think. No, it was 6 plus x minus x squared, and that was between -2 and 3, and there we go. We have the answer 20.833 given, and that's 20 and 5/6. That seems to be good. And there we have it. Integration between two curves, subtract, integrate, and we have the area between. That's our problem finished.